希望这片山林能越来越好。
明年整个国王公园1.46万平方公里都会有红外相机的监测。
I want to start by thanking the enterprise users and ecosystem partners who have been supporting big data products of Huawei Cloud, as well as the technology enthusiasts with long interest in these products. It's a pleasure to give an update of Huawei's FusionInsight MRS live online. Hopefully, with the efforts we've made, we may win your recognition again. My topic today is Huawei FusionInsight MRS, one lake for one enterprise, one lake for one city. Nowadays, big data is no longer a new term. More examples have told us that big data is a revolution. It is a combination of many technologies that can break the boundaries between the digital and the real world. It gets the two worlds connected to enable the digital economy and grow the real economy. In a modern enterprise, operations are run through processes. How do we tell if a process is agile and efficient? How do we identify process inefficiencies to drive improvement? These are important questions when business managers make decisions. That's where data plays a decisive role too, as data can best reflect the operational performance of a company. More importantly, collaboration and dependency between processes require real-time and accurate flow of data. This means that all the data coming from processes must be converged. There can't be data silos. That's where the notion of one lake for one enterprise comes in. It's a key step toward a full enterprise intelligence. The idea can be expanded to a city. A city has many functions that allow residents to live and work in the city. With the internet revolution, cities have been digitized, but not smart enough. Why? It is because data are not shared and openly accessible. Data are scattered, fragmented, and cannot flow easily across city functions. They cannot flow into our work and life precisely in real time. So we put forward the idea one lake for one city as the foundation for smart cities. Let's look at an enterprise core processes. Manufacturing is crucial for a company. How to ensure a reasonable planning and scheduling? How to plan for a reasonable level of inventory? How to enforce quality control? What's the right design for material supply? How to ensure logistics matches supply chain? Data are indispensable to answer these questions and ensure we make the right decisions. But often, big data systems in different domains are not built at the same time. They are almost certain to be fragmented at the beginning, and the questions just now can hardly be answered because data from different manufacturing activities are not integrated. So even with data, we cannot have the answer. That's where the enterprise-wide data lake comes in. It's the cornerstone of intelligent operation and management. The chart shows the Kanban for real-time analysis and decision-making in Huawei supply chain. Smart manufacturing is the initial core process. As the company's business continues to expand, quality control and smart logistics have been built and improved. Much data are generated in the day-to-day operations. Smart supply chain management and city-wide and flexible manufacturing have also emerged. These domains are inseparable from one and another. Data converge and flow freely to help the operational system make the right decisions. Kanban for production operations allows for visualization and intelligence. The enterprise-wide data lake helps Huawei to break the bottlenecks. Let's take a look at the city of Shenzhen. People, production, and living are the basic elements of a city. They are the building blocks of its governance, transportation, dining, trading, and living, etc. Each activity of an enterprise or of a person has contact points with these elements, and these contact points have been informatized with the wide adoption of the Internet. All this information are transmitted through the city's 700,000 base stations. However, a smart city is much more than data transmission. This data must be able to converge, share, and flow across various urban functions before the city and our lives become truly smart. We needed this information to come together to make informed decisions. For example, when I go and apply for a passport, the navigation system will tell me the best route. The subway and the bus system will tell me the easiest way to get there. But this traffic data don't know the opening hours of the passport authority. And these transportation systems and the passport authority don't know that I also want to have a lunch afterwards. At this point, I need 3 pieces of information altogether to make a decision so that I can be back in the office by 3 p.m. for an important meeting. This is a typical case that requires data convergence in real time. Every resident is constantly sending and receiving data from 5G base stations with smart devices. Explosive growth of data has become a reality. Meanwhile, these data are increasingly complex and diversified and increasingly require real-time processing and flow. Fragmented data cannot meet the city's growing demand. Only a city-wide data lake plus 5G can fully deliver the promises of a smart city. To summarize, for enterprises and cities, business needs and technological innovation have become the dual drivers for growth. The massive growth and the convergence of data has fueled a new momentum to the digital economy, shaping the landscape of business investment. This will certainly accelerate the digital and intelligent transformation of governments and enterprises. Data convergence to form an enterprise-wide or city-wide data lake will become the key. And to deliver such a data lake, having a digital foundation is crucial. As a typical big data platform, Huawei FusionInsight MRS has been widely adopted. To deliver on the vision of enterprise-wide or city-wide data lake, the platform must be powerful enough to break 5 bottlenecks. The first is continuity bottleneck. The platform must be highly stable to ensure business is always online and rock solid. Second, scalability bottleneck. One cluster contains up to 20,000 nodes, and clusters can be federated to form a larger logical cluster, enabling unlimited capacity expansion. Third, performance bottleneck. Data supply efficiency can be improved from T+1 to T+0 within seconds, within a PB level data volume. Fourth, convergence bottleneck. More business scenarios have led to various engines with differing computing powers, but not a single engine can satisfy all use cases. Therefore, multiple engines and various computing powers must be converged in the data lake. Fifth, geographical bottleneck. Data centers of enterprise are mostly built in different locations in the city. It's unrealistic to constantly move or copy data for analysis. The platform, therefore, must allow for unified SQL access across different sources and geographies. The ability to break these 5 bottlenecks is a key indicator to distinguish between different big data platforms. Huawei FusionInsight MRS has been well verified in real cases, and it can fully satisfy the business needs around enterprise or citywide data lakes. In the digital age, the production system increasingly needs the decision outcome of the analytical system. It needs to become part of the production system. This is a typical example of data convergence and data flow. The analytical system should be always on 24/7 like the production system. This is the ultimate goal of breaking the continuity bottleneck. At Huawei, FusionInsight MRS has been deployed to support 50 nodes at the beginning, then 2,600 nodes, and then over 10,000 nodes. The platform has been delivering the promise of ensuring the cluster is always online. In addition to non-stop stable operations, FusionInsight MRS also supports online routing upgrade and zero service interruption with 5 nines reliability. For some mission-critical applications, high reliability is required with an intra-city plus remote DR, or even 2 locations and 3 centers of DR. FusionInsight MRS has an RTO of 0 and an RPO close to 0. In terms of data size, growth is infinite, and the technological architecture has to cope with it. In other words, the maximum capacity of a single cluster must be big enough to support explosive data growth, or multiple clusters can be federated to form a super large logical cluster. So far, the MRS platform can support up to 20,000 nodes in a single cluster, which has been certified by the China Academy of Information and Communications Technology. 11,000 nodes have been delivered in production. In addition, resources in cluster can be partitioned based on the load requirements of tenants. These resources are isolated. You get what you see. The resource load of the entire cluster is automatically managed through a unified resource scheduling system. MRS has made functional enhancements based on Yarn. The superior of components based on Yarn's resource manager and automatically manages task priorities to ensure best utilization. The One Lake architecture offers a one-stop solution to multiple scenarios such as AI, BI, batch, stream, or convergence. They are no longer limited by technical architecture. In terms of data consumption, most analytics in big data clusters involve a rather lengthy process. The source data are collected from the production database and then get processed before they enter the lake. This process can hardly be sufficient when it comes to massive, concurrent, and interactive queries. To ensure faster response to such queries, development teams typically migrate the processed data to RDBMS to form topic-based data marts, and yet such model can only deliver T+1 response. Processing and moving data around several times from production to consumption would also mean that the efficiency of data supply gets lower. Is it possible that a single copy of data across the lake can satisfy all the needs? Can we shorten the route of processing so that data supply efficiency increases to T+0? That's where carbon data comes in. It's a storage engine that Huawei contributes to the open source community. It gets productized in MRS and used in the storage layer of the data lake. Carbon data enables real-time update of incremental data while preserving historical snapshots to deliver T+0 performance for data analysis. We now have a combination of a real-time data warehouse that's built on open source ecosystem, as well as an offline data warehouse that's mature. Both batch data and stream data can be analyzed. It greatly satisfies the business demand for real-time analysis, early warning, and forecast. Let's take a look at the performance. We tend to believe that traditional all-in-one appliances always have better performance. But in our internal sourcing test, we found Spark actually has better performance and much better scalability. The He2 engine in MRS can respond to interactive queries in seconds. We don't have to move data to analytical RDBMS or all-in-one machines to get a faster response to most interactive queries. In an open source system, engine diversification is most commonly seen. That's because data analysis today spans multiple geographies and involves diverse computing powers, complex data types, and heterogeneous data sources. There's no perfect engine suitable for all scenarios. And the level of convergence across computing powers and engines across data sources and domains and across cluster resources becomes an important indicator of a platform maturity. First, cross-domain convergence. Users have visibility of global data. Cross-domain collaboration becomes easier, and the response time is reduced from days to minutes. Second, cross-source convergence. The He2 engine not only realizes unified SQL access in the lake, but also coordinated access between lakes and between the lake and an MPPDB. Third, multi-engine convergence. The He2 engine has a unified application interface that connects with the upper channels and applications. Users only need to access one SQL engine. Fourth, resource convergence. Resources in the cluster are consolidated into a large resource pool and managed centrally through Superior. Resources can be dynamically provisioned to different tenants with isolation. Fifth, computing power convergence. MRS is good at accommodating different hardware resources. CPU, NPU, and GPU can be all unified in the hardware resource pool in a way that's application agnostic. Through these 5 levels of convergence, enterprise and city-wide data lakes can become a reality to make data analysis simpler than ever. Here are a few examples in production environment. MRS is used by Huawei for its process and IT operations. The one data cluster has been expanded to 11,000 nodes and certified by CAICT to support up to 20,000 nodes. It is a benchmark in the industry. The cluster has gone through several rolling upgrades and expansion with zero service interruption and over 6 years of stable operations. The cluster hosts 448 PB of data with 580 GB per second peak writes, over 100 TB new data, over 10,000 ad hoc queries, and 100,000 batch processing tasks on a daily basis. At the application layer, MRS is delivering more than 100,000 reports to over 10,000 users for operation or analytical purposes across over 50 products. This is a massive scale, and response time is only 5 minutes with only 1,000 O&M metrics. This is a platform that continues to evolve, always online, super large in scale, and solid in performance. We also have a case of a large standalone bank. It's one of the early large customers who have adopted Huawei's MRS solution. After years of efforts and several major rolling upgrades and expansion, the platform has 2,500 nodes, and a single cluster supports a maximum of over 1,100 nodes. The services enabled include customer profiling, risk information, intelligent semantic recognition, intelligent recommendation, text recognition, and ad hoc analytics. The platform also enables continuous service innovation. Several innovative products that are pace-setting have been launched. With the support of MRS, the bank has evolved this big data platform to follow an enterprise-wide data lake architecture. Data get converged across the board, and the value of data is further unleashed. Guangdong Mobile is one of the first large customers to do online rolling upgrade and capacity expansion on Huawei's MRS platform. From 2018 to 2020, there's major upgrade or expansion of its production environment each year. With Huawei products, there's been zero accident out of such major changes. Big data applications are inherently iterative, as the open source community is vibrant and there's fast iteration in the user's business environment. Particularly with 5G, faster service iteration will become the norm. How to ensure that large production systems can be maintained and changed easier? That's an area that Huawei's R&D team has been exploring. Only with the right O&M assurance can we deliver service continuity and efficiency. Powering off, restart, long service interruption for expansion or upgrades, or service outage caused by faults are all unacceptable in the production environment. Over the years, Huawei's MRS product has gone through nearly 100 large-scale upgrades. We've got rich delivering experience and emergency handling capabilities, particularly 40-node isolation, which can ensure service continuity during O&M. In addition, Huawei's refined O&M methodology and the GUI-based dashboard make O&M more agile than ever. That's all my presentation today. To conclude, I hope Huawei's cloud products and the technology community will continue to have your support. I also hope Huawei FusionInsight MRS can grow together and bring value continuously to our enterprise customers and ecosystem partners. In the future, your support will always be the growing driving force of our continuous progress. Thank you all again. See you.
大家好。
Hello everyone, I'm pleased to share with you the Huawei's next generation enterprise-level data warehouse.
With the rapid development of 5G, AI, cloud computing, and IoT technologies, industries are digitalizing rapidly, posing new challenges to the data analysis platforms. First, data is growing exponentially. According to statistics, the global data volume will exceed 180 ZB by 2025. Therefore, the scale of the data warehouse system that stores high-value and dense data will be increasing. The scale of the data warehouse system will grow from dozens of nodes to hundreds of nodes, and will even to thousands of nodes in the future. This poses higher requirements on the scalability of the data warehouse system. Second, enterprises have entered the era of converged data analysis dominated by structured data. Converged analysis of semi-structured and unstructured data such as time series data, stream data, space data, and text data is the trend in the future. New computing power such as ARM and GPU are emerging continuously. The system needs to mobilize diversified computing power to provide converged analysis capabilities with higher performance. Third, mobile internet and office online carried out through apps have become basic elements of people's daily life, which raises higher requirements on the stable running of data platforms 24/7. Let's look at the development history and trend of the data analysis. The development of data analysis products have gone through 4 phases: single server, cluster, distributed, and cloudification. The first phase was the PC era. In the 1960s and 70s, PCs emerged. The data analysis services mainly consisted of simple query and data aggregation, which was the early data marts. Typical data analysis product was Oracle single-node database. At that time, the system featured basic availability. The second phase was the Internet era, from 1990s to early 2000s. The Internet became widely popular. All-in-one appliances such as Oracle, Rack, Cluster, Teradata, and Exadata were very popular, and the first TB level and a PB level data warehouse systems came into being. The third phase was the mobile internet era. In 2010, e-commerce boomed, mobile internet developed rapidly, and data volume increased unprecedentedly. The Hadoop system based on the general-purpose x86 platform and the MPP database began to penetrate the market. Those systems can process and analyze structured and semi-structured data and feature distributed deployment and high scalability. The fourth phase, which is right now, is called the intelligent data era. In recent years, cloud computing, IoT, AI, and 5G technologies have been widely used. Massive and diversified data, especially time series, stream, text, and video, require further processing and mining. Data processing will be based on the cloud. The collaborative computing through data warehouse and big data will expand the computing boundary. Converged analysis of data warehouse plus AI will align structured and unstructured data and discover more value from data. Therefore, we released the next generation GaussDB real-time data warehouse. It supports real-time convergence analysis of stream data, time series data, and relational data. It is fast, easy, simple, and cost-effective. The first point is fast. Fast import. In typical IoT scenarios in the future, with the increase of number of device accesses, there will be an exponential growth of the data generated instantaneously, which need to be quickly imported. The real-time data warehouse can support a continuous calculation and import rate of up to 600,000 per second for stream data and up to 100,000 per second single-node performance for time series data. In addition, it supports linear expansion based on the data volume of cluster nodes. Second, fast computing. It supports continuous stream computing and a query based on stream data definition and semantic definition of complex stream computing based on SQL. It also supports rolling and sliding time window to implement real-time analysis of stream data by time granularity. Second, easy. It supports semantic definition of complex stream computing based on SQL, which simplifies application development. Take a Druid monitoring scenario as an example. With SQL statements, we use 150 lines of code to implement the same functions as the original 1,900-line Druid scripts. It supports real-time multi-dimensional analysis so that a multi-table correlational query can be performed for relational tables and time sequence tables. Third, simple. One platform can implement continuous computing, rule computing, pre-aggregation, and time sequence computing, which significantly simplifies development and O&M. GaussDB features high compression ratio. Time series data has certain inherent rules. The real-time data warehouse uses adaptive compression algorithm to achieve a compression ratio of up to 40:1, greatly reducing storage space and the user costs. The release of real-time data warehouse was not achieved overnight. In fact, we have been working in data warehouse field for nearly 10 years. From the end of 2011 to 2013, we set up database R&D teams in multiple regions in and outside of China. We started product prototype development and verification and made breakthroughs in basic distributed architecture technologies such as distributed framework, role storage, and HA. In 2014, our data warehouse products were put into commercial use for the first time. Our products have basic features of modern data warehouses such as data partitioning, column storage, vectorization engine, and compilation execution. From 2015 to 2016, we continued improving products together with customers and started setting up benchmark cases in the finance, government, and telco industries. We also made breakthroughs in advanced features such as large-scale cluster communication, dynamic load management, and SQL on Hadoop. By 2019, GaussDB has been put into large-scale commercial use, with more than 300 commercial cases of key accounts. In addition, the product added innovative features such as multi-tenant, SQL on OBS, and a global consistency backup and restoration. Up to now, more than 1,000 customers worldwide have chosen GaussDB to build their core data warehouse systems. In addition to these next-generation competitive edges of real-time data warehouse, GaussDB won the trust of many key accounts because it has solid capabilities. Its three core features are large, fast, and stable. The first feature is large. Based on the shared nothing distributed architecture, GaussDB achieved breakthrough in key technologies such as large-scale communication and large-scale cluster management. Its design specifications reach 2,048 nodes, which enables high scalability. GaussDB can start from a small scale and can be extended to hundreds of thousands of nodes on demand. The cluster performance and capacity will increase linearly as the number of nodes increases. For example, one key account has built a GaussDB cluster that will soon exceed 480 nodes and nearly 10 PB of data. In addition, we are operating more than 10 large clusters with PB level or higher data volume stably. We continue optimizing core technologies such as communication, cluster management, and optimizer to enable GaussDB to effectively support 100 PB enterprise core data warehouse systems in the future. Next, let's look at the second feature of GaussDB, fast. First, GaussDB features a multi-layer full parallel computing engine which supports parallel computing of multiple physical nodes. Within one physical node, it supports parallel computing of multiple CPU cores, and within one instruction sequence of a CPU core, it supports SIMD instructions, so that one instruction can operate multiple data at the same time. It can be said that the GaussDB maximizes the parallel capability to provide ultimate performance. In addition to full parallel capability, Huawei also implements core technologies such as next-generation intelligent optimizer technologies, efficient operator algorithms, and dynamic compilation. With parallel computing power and efficient instruction, we can implement ultra-fast data loading and analysis. Currently, in commercial sites on the live network, we have realized TB-level data import in minutes and association analysis of 10 billion lines of data in seconds. As an enterprise-level data warehouse product, GaussDB's third important feature is stable. All components of GaussDB, such as CN, DN, GTN, and CM server, can be deployed in active-active or active standby mode to ensure smooth switchover when a single component is faulty. In a product deployment solution, critical hardware such as disks, switches, and ICs and host power supplies are deployed with redundancy networking design. In addition, during large-scale commercial use, we have improved and implemented comprehensive software and hardware fault detection, including faults of switch, NIC, disk, RAID controller card, host, hardware sub-health, and cluster software instance. Due to the multi-layer backup of hardware and software and comprehensive fault detection, when a hardware or software fault occurs during cluster operation, the cluster can quickly detect and respond to the fault and automatically switch over, ensuring data integrity and service continuity. In the future, GaussDB will continue to innovate and evolve. We will keep making efforts and optimize the following 5 aspects to build a new generation all-scenario cloud data warehouse. First, continue optimizing the enterprise-level kernel capability to support larger cluster scale, stronger real-time analysis, and higher system reliability. Second, faced with cloud, we will continue optimizing wizard-based full-process O&M capabilities with online visibility, and online, fast, and elastic scaling capabilities to build a cloud-native data warehouse. Third, continue optimizing data collaboration capability to enable one cluster to support multiple service systems of different types, making data collaboration and analysis across data sources, regions, and clusters simpler and more efficient. Fourth, keep exploring new hardware capabilities to enable products to adapt to more hardware platforms. On the other hand, keep drawing on new hardware dividends and software-hardware joint innovation for stronger end-to-end system capabilities. Fifth, continue expanding the data analysis boundary and realize the association and converged analysis between AI and BI, structured and unstructured data, and real-time and historical data. Lastly, to harness the rapid growth of massive and diversified data, DB will keep evolving to provide customers with competitive, all-scenario, and cloud-based data warehouses. That's all of my sharing today. Thank you.